Dear students, let us consider another property of the coefficient of correlation. This property states that rho xy is equal to rho yx. इसको कहा जाता है the property of symmetry. हम कह सकते हैं कि एक symmetry इसके अंदर है. Now exactly what do I mean? When I say rho xy, what will be the formula, my dear students? The formula would be covariance of x, y divided by the standard deviation of x into the standard deviation of y. नोट करें कि मैंने आपसे कहा रो एक्स वाई यानी x पहले कहा y बाद में कहा, तो फॉर्मूले के अंदर भी मैंने उसी ऑर्डर में बात की. अब अगर हम इनका x और y का रोल जो है उसको इंटरचेंज कर दें, so then what will we have? Obviously, we will have rho yx यानी x की जगह y और y की जगह x. तो फिर वो जो फॉर्मूला है, what will that become? It will be the covariance of yx over the standard deviation of y into the standard deviation of x. अब ये जो दोनों फॉर्मूले हैं, अगर ये बराबर हैं, तो फिर जो मैंने कहा that is correct. तो क्या ये दोनों फॉर्मूले बराबर हैं? Well, just first look at the denominator. पहले वाले में डिनोमिनेटर के अंदर क्या था? स्टैंडर्ड डिविएशन ऑफ x मल्टीप्लाइड बाय द स्टैंडर्ड डिविएशन ऑफ y. दूसरे वाले के डिनोमिनेटर के अंदर क्या है? स्टैंडर्ड डिविएशन ऑफ y मल्टीप्लाइड बाय द स्टैंडर्ड डिविएशन ऑफ x. ऑब्वियसली दे आर एब्सोल्युटली द सेम. और अब अगर आप न्यूमरेटर को देखें, पहले वाले में कहा कोवेरियंस ऑफ एक्स वाई. हम जब लिखते हैं तो हम किस तरह लिखते हैं? हम लिखते हैं COV, उसके बाद ब्रैकेट के अंदर x, y, और दूसरे वाले में y, x. लेकिन बात यह है कि आप इसके फॉर्मूले की तरफ देखिए ना. What is the formula of the covariance? Well, the covariance of x, y is equal to the expected value of x minus e of x into y minus e of y. इसी तरह, what is the formula of the covariance of y, x? Well, obviously it would be expected value of y minus e of y into x minus e of x. Once again, it is obvious that both of them are absolutely the same, because 2 into 3 is the same as 3 into 2. So this is a very interesting property of the correlation coefficient, that rho xy is equal to rho yx. All right, let us now consider another property. And this property says that the coefficient of correlation measures only the linear correlation between x and y. It measures the strength of the linear relationship between x and y. What do I mean by this? We must revert to the scatter diagram, which is a very elementary concept when we talk about the relationship between two variables, and a very important concept at the same time. देखिए, जब आप स्कैटर डायग्राम बनाते हैं, अगर वो पॉइंट्स जो हैं, if they are going upward, suppose, and it appears as if they are going along a straight line, yani not exactly a straight line, but if I were to draw a curve through those points, my dear students, if that curve is actually like a line, then this is what is meant by the linear relationship between x and y. और जो रो की वैल्यू है in case of an upward diagram, जब हम कहते हैं कि अगर upward जा रहा है तो it would lie between 0 and 1, excluding 0 but including 1, तो इसको अंडरस्टैंड करना भी तो बहुत ज़्यादा ज़रूरी है ना, कि ये जो वैल्यू 0 से 1 के बीच में है, उसकी जो एग्जैक्ट वैल्यू होगी, what would that mean with reference to this linear upward going scatter diagram? दिस इज वाइटली इंपॉर्टेंट. इसको समझ लेते हैं, कोशिश करें इसको समझने की. बात यह है कि the closer the points are to this upward going line, the closer your row would be to 1. यानी एक लाइन अगर बीच में से गुजर रही है और पॉइंट्स जो एक्चुअल पॉइंट्स हैं, they are actually very close to that line, then we say that there is a strong linear relationship, and in this case a strong positive linear correlation between x and y. So ये प्रॉपर्टी जो है, इसी तरह की बात ऑब्वियसली हम डाउनवर्ड गोइंग स्कैटर डायग्राम के केस में भी कर सकते हैं. और जैसे मैंने कहा कि प्रॉपर्टी गोया फिर यही है कि कोएफिशिएंट ऑफ कोरिलेशन मेजर्स only the strength of the linear relationship between x and y. Last but not the least, I would like to present to you another property. And this one is as follows. Dear students, if the two random variables x and y are independent, and you already know what is the concept of independence, then the coefficient of correlation will be exactly equal to 0. Now let me say it one more time. अगर x और y independent random variables हैं, तो coefficient of correlation जो है, that will come out to be exactly equal to 0. But please note that the converse of this statement is not necessarily true. All right? The converse of this statement is not necessarily true. अगर आपका coefficient of correlation, linear correlation coefficient 0 आ गया है, तो that does not necessarily imply that x and y are independent random variables. However, if x and y are independent random variables, then the coefficient of correlation between those two variables will be 0.